So now the last thing, we want to add a simple camera and then create a camera class. Probably I'll not do the class, I'll just add the camera and then show you some camera movement or something like that. Okay, so we need to add a view matrix and a projection matrix, right? So let's get to that. I'm not going to change anything in the shapes, so I'm just going to close all these things. I'm going to stay consistent with what we have now and just add the camera to this scene. Okay, so the first thing, we need a view matrix. So let me create a view matrix first. I'm not doing any of this here anymore. So I'm going to create a matrix, and that is a new matrix 4, right? Matrix 4. Right. And then we are going to need a projection matrix. And a new matrix, right? So the view matrix and projection matrix, these two are going to create our camera. This is going to set up our scene, how we are going to view the object, and the projection matrix is going to set up if this is going to be perspective or orthographic. It depends on what type of parameter you're going to pass. First thing is how we're going to set up our view. So this is where the viewer is going to stand and where the viewer is going to look. How to set up view matrix, I think there are quite some good examples in the book. But first thing is let us set up this, and then if we have time, we check more. Okay, so we need to do the common tasks. These are going to be in our shader. So in our shader, we're going to add this matrix just like this. So this is going to be an uniform. Another uniform. So this is view matrix. This is going to be our projection matrix. And then let's first do the view matrix. So for all uniform, we need to do this extra steps, right? After the definition, we need to create this. So for the view matrix, let me create this first. So this is view matrix. Did I name it right here? Yes, view matrix. This is also view matrix. And view matrix. So this is going to be our view matrix and elements. I think we're good. Okay, so let's take a quick look at our library function, the matrix function. You'll see specifically for the view matrix, we have here something. So set ortho, these are for projection matrix. There is something called look at. Set identity. Set ortho, set first one. Set perspective. Set scale. Rotate. Look at, yeah. So this is what I was looking for. So this look at function, if you take a look at the documentation, it has 9 parameters, right? So the first 3 are the location of the eye, the position of the eye, and then you need to set up the center of the reference point. So where the eye is going to look at. And the up vector is sort of how you position your camera, right? So the up vector is for, like, if you, the standard way we hold the camera, the up of the camera is towards the y-axis, right? So for our case, the up vector is going to be y-axis. But what I'm going to do, I'm going to set the lookup. So there should be another function called set lookup. Set lookup with the same parameters. So I'm going to set lookup for the view matrix using this function just after defining the function. So set lookup for the view matrix. Now we need these 9 parameters to set up properly, and then we'll be able to see our object. Okay, so the first 3, the location of the eye, right? So where the camera is going to be. Let's make that for now 0, 0. Let's put this maybe to -10. So this is z-axis, right? So if we look at our screen, so towards the screen is the z-axis, right? So our camera should be a little bit far from the screen so that we can see. If it is on the screen, the camera is going to be on the top of this shape, right? Will not be able to see anything. So I'm going to make it -10. And then for the center, I'm going to look at exactly where the shapes are. So I'm going to look at exactly the center. So I'm going to make the center 0, 0. And then the last 3 is the up vector. I know that the standard camera up vector is along the y-axis. So I'm going to make y the up vector. Okay, so our set lookup is done. Then this is done. Okay. At this point, I'm going to apply the view matrix in our shader and see if it works. So I'm multiplying it with the model matrix. See. Okay. I don't see anything. Probably it is too far. Let me make it closer. Yeah, it's better. So if I make it 2, oh, that's not going to work because that will go outside of the view. But if I make it maybe 0.5, that is going to work, right? So you'll not see the effect here, but 1 is the highest limit. So because our axis is in between -1 to +1, we cannot go farther from the -1, right? So this is already quite far. Okay, so set lookup is done. Now we need to work with the projection matrix. So what are the component of a projection matrix? So we can have 2 different types of projection, right? Orthographic or perspective. So our assignment is asking us to do the perspective projection, I believe, somewhere here. Yeah, using a perspective camera. So there is a function in the matrix that is called set perspective. See, we have a step first term, set perspective. This is what we are going to use for this function. So there is a field of view along the y-axis. So that is how wide it is going to be. The lens is going to be along y-axis. The aspect ratio and the near plane. What is the nearest plane where you can see, and the far plane. So set perspective, and then I'm going to use that with the projection matrix. Okay. So the field of view can have some sort of angle. Let me make it narrow angle. Wide angle would be much wider, maybe 120 or something. 60 is okay. And then in the aspect ratio, which I'm going to calculate from our canvas width and height. You did that for your assignment 0, I think. Height, right? Then in the near and the far. So let me set the far as 100 and near as 0.1, just above the screen, right? Yes, this should work. Once that is done, we need to set this up with the shader, just the same way we did for the matrix. So now we have this projection matrix, and this is also projection matrix. I believe there is no typo, so I'm going to quickly go ahead and then multiply the projection matrix here. So okay, as you can see, because I have this wide angle camera set up now, I have this. This is sort of cropped on the top and the bottom. So we can actually make this lens sort of wide angle lens, and things will be much smaller. So let's make this 120. I think that's the standard wide angle lens iPhones and other phones have. Yeah, now this is much smaller because this is field of view alongside y-axis. So the higher the angle is going to be, the more area it will cover, right? So this is more like if I draw from the using the annotation. So this is now our angle of view, right? That's why we can see wide area. But last time the angle was something like this. That's why we only saw part of the house. I don't know if that makes sense, but the smaller angle would crop things up. If I even select even narrower angle like this, you'll see we'll only see the middle portion of the house. So this was 60, the widest one is 120, the new one can be 30. So let me clear this and change the angle to 30. So we only see like part of the house, right? So let's go with maybe 90 or something. Should give a better view. Let's see if I can do some sort of animation in about. Okay, this rotation. So now the view is more realistic, right? Like unlike the last time, you can see some artifact here, but yeah, unlike the last time, it's coming closer to the camera, and then something like that.